algebraic using conjugates. So again, see how they gave you a key? The conjugate, okay? This one it's going to look a little bit different for you because it have a lot of symbol. But this tells you the limits as, this is called delta x, as delta x go to 0. It's just the variables, a symbol. Are we okay? Delta x means is the change in x. So as the change in x get closer and closer to 0, that means there's really no change. So but like it's like the 2 point getting closer together. That's what this means. Then this is my function, the square root of 3x plus delta x minus the square root of 3x divided by delta x. So now if this delta x go to 0, if I plug in 0, do you guys see that my denominator is 0? So now I have a problem because I cannot find my limits. Do you guys see that? So when you have that, you're going to have to multiply by the conjugate because this is square root. Is that okay? For convenient purposes, instead of writing delta x, I just change that to h. Is that okay? Because I don't want to keep writing the triangle and x. So I can pick another variable and just put it in there. Just know that delta x, I just rewrite that as h. So now what I want to do is I want to multiply by the conjugate. Yeah? Take a look at your term. Notice for the previous example, we only have one square root and a constant. Did you guys see that? In this case, we have two square root. That's okay. You can still multiply by the conjugate. So the conjugate for us is going to be the square root of 3x plus h. So same term, but opposite signs right here between the two terms. So if this is a negative, this have to be a positive. So that's a plus square root of 3x. And you're going to have to do that to the top and the bottom. Okay? Because essentially you are multiplying by 1. So it will not change your ratio. Okay, see if you can multiply it out. I think we should have enough space, huh? If you want to write down or you want to write across, I don't really mind. Yeah, I'll write down because we should have plenty of space here. All right, you guys find out what it is. Multiply it out for me. Multiply it out. Are you guys done? So the square roots have a square root. Since they are identical, I'm just going to get the radicand back, which is the one inside, 3x plus h. Okay, so the square root will cancel out. My middle term will cancel, so I don't have to care about distributing that in, but I have to multiply the last term with the last term. So a negative root 3x times a positive root 3x is going to be negative 3x. Since your square root will cancel out. Are we all right? Yes or no? Okay. Just know that when you multiply square root, if they are identical in terms of the radicand, the inside terms, then your square root just go away. You just write that term back. That's what it is. Okay. All right. Then I'm gonna have this one. I have h. Okay. Then I have that whole mess that I have there, my conjugate. So I'm gonna write that the square root of 3x plus h. And then plus the square root of 3x. There you go. Okay. Now that I have that, I'm going to clean this up. 3x minus 3x, that's a 0. You guys see that? So on the numerator, I only have h left. Is that all right? On the bottom, my denominator, I have h, and then the square root of 3x plus h plus 3, the square root of 3x, right there. But now look, do you see the term? The term that makes your function undefined is that denominator, which is the h. And now the h is being canceled out. Do you guys see that? That's what you want. So you want this to eventually cancel out. And so what I'll get is, I'm going to write the limit one more time because I want to remind you that even if this thing cancels and there's nothing on top, you got to write 1 for me. You don't bring that thing on top, okay? So what you're going to have left is the square root of 3x plus h plus the square root of 3x. Now that we have this, we can then try to substitute in 0 for that h. Do you guys see that? Because the h is no longer in the denominator, which caused your function to be undefined. So now, once I plug it in, do not write the limit anymore. So you're going to get 3x plus 0, and then plus the square root of 3x. What I'm going to get is 1 over, that's the square root of 3x plus the square root of 3x. What is the square root of 3x at a square root of 3x? What's that equals to? What is it? Huh? No. You have 1 of this term, you add another 1 of that term, you have 2 of that. So 1 root 3x, whenever you add, you can only add the coefficient, okay, of that. These are called like terms. So it's like, a plus a, that's 2a. So this is 1 root 3 and another 1 root 3. So 1 root 3 plus 1 root 3 is 2 root 3. It's not the square root of 6. You don't add the 1 inside. Okay? That doesn't work. Are we all right? So be very careful with that. Okay? So your limit is this value right here. Questions? It's a lot of algebra. You guys see that? One thing I want to make sure. Let me introduce a vocabulary for you. This is a new one, and then we'll stop. In the previous problem that we did, do you guys see that when I plug in a -8, my denominator is 0? But do you see that my numerator is not? If I plug in a -8 here and a -8 here, I'm going to get some number. It's not 0. It's going to be some number. Are we okay? Same thing here. If I plug in a 5 here, I'll get 0 here. But that's going to be what? Oh, that's also 0. Do you guys see it? So when you have the numerator is 0 and when the denominator is 0, we have a name for that situation. We call that indeterminate form. Okay? So when you have the numerator become 0 and the numerator becomes 0 and the denominator becomes 0, the name for that is indeterminate form. That's the 0 over 0. Okay? So we're going to have to write that here. So go back to example 3. This is called indeterminate form. Now, indeterminate forms is this form right here. That's 0 over 0. Okay? However, I got to tell you this. On the AP exam, if you write this, they will not give you a point. Because mathematically, this is incorrect to write. Is that okay? So we're going to talk about how to write it correctly so that they going to give you a point for it. We'll talk about that later, but not right now. Is that good? When we have to deal with that, we'll talk about it. But understand, indeterminate form is when you have, in this case, 0 over 0. Okay? If you don't have it, if you only have 0 in the denominator, that's not indeterminate form. Okay? So now if I'm looking at this one, if your delta x is 0, so I can plug in 0 here and 0 here, then I have the square root of 3 minus the square root of 3, which is 0, and 0 here. So in this case, this is also indeterminate form. Are you okay? So this is called indeterminate. Okay? Indeterminate. So that's 0 over 0. Now, the reason you have to know that is because a long time ago, there is a gentleman that discovered a shortcut to finding limits. But he only discovered that if the form is indeterminate. Is that okay? So later on, when we learn his strategy, his techniques, you have to first determine if it's indeterminate or not. Okay? Because his formula only works if it's indeterminate form. All right, we're going to stop there. Let's go ahead and